Tonight, we're going to measure a word your brain was never built to hold. Forever usually lives in feelings. We use it when something seems endless, when time feels slow, when we're waiting, when we're afraid, when we're trying to describe a promise that doesn't fit inside a normal day. But the universe doesn't treat forever as an emotion. The universe treats it as a question you can try to answer. So let's ask it plainly. How far is forever? Is it a distance you could travel if you just kept going long enough? Is it a time you could wait through? Or is it something stranger, a limit, a boundary, a line you can approach but never cross? Because if the universe contains edges we can never reach, then the idea of travel changes. It stops being about speed and courage and technology. It becomes about what the universe allows, what it forbids, what it hides behind distance and time. And there is a reason your intuition struggles here. On cosmic scales, distance and time are tied together. Light carries information, and light takes time to cross space. Even the sunlight that warms your skin is already minutes old when it reaches you. Your brain edits that delay into the present because it's small enough to ignore. But the rule never changes. The rule only scales up until how far becomes indistinguishable from how long ago. This is where most people misunderstand the universe. They imagine that if you wait long enough, you can eventually reach anything. But physics has a name for the kind of boundary that makes that untrue. A horizon, a limit not of bravery, but of access. By the end of this journey, you'll know what is reachable, what is not, and why. You'll understand the first edge, the boundary of what we can see. And then you'll meet the second edge, the boundary of what we can ever reach, even given infinite patience. And that's the part that quietly changes everything. Because the universe may be larger than it looks, and still unreachable in the ways that matter. And the strangest part is this: forever might not be something waiting ahead of you. It might already be closing behind you. Your mind is good at certain kinds of distance. It understands rooms, a few steps to a door, the length of a hallway, the space between you and a window. You don't calculate it, you feel it. Even with your eyes closed, you can point to where things are because your body has learned that scale. Step outside and your intuition still works. A street, a block, a neighborhood, a mile becomes a walk you can imagine. 10 miles becomes a drive. 100 miles becomes a trip you plan. Even crossing a country can be reduced to hours in a plane, a simple schedule on a screen. But there's a threshold where your brain stops holding distance as a lived reality and starts holding it as a symbol. You still understand what the number means, but you don't truly feel it. That isn't a flaw in you. It's a feature of evolution. We grew up in a world of meters and minutes, where the horizon was a practical limit, and the largest distances were measured in days of travel, not in the lifetimes of civilizations. To prepare for forever, we need to notice the moment distance becomes time. Imagine the Earth the way astronauts see it, a quiet sphere of blue and white, continents and storms, everything you've ever known compressed into a surface you could cover with a thumb. From that perspective, your biggest road trips become tiny lines. Borders disappear. The world feels smaller not because it is small, but because your viewpoint changed. Now add the moon. The moon looks close because it is familiar, but it's about 384,000 kilometers away. If you could walk toward it without stopping, it would take more than 8 years. Already, distance is starting to behave like a test of patience rather than a test of speed. Now add the sun. Light takes a little more than 8 minutes to reach us. 8 minutes doesn't sound like much, and for a human day it is, but it reveals something important. Even in your ordinary life, information arrives late. Your brain simply edits the delay into now. This is where the pattern breaks. From here onward, distance isn't measured in miles the way your mind prefers. It's measured in light travel time, minutes, hours, years. And once you start measuring that way, you begin to see why forever is not just a feeling. It's a scale. Now we're going to cross the first distance your mind can't picture. The first true step into forever is simpler than it sounds. It's light. Light is how the universe delivers information. It carries images, colors, heat, and every distant detail you think you are seeing. But light is not instantaneous. It travels at a fixed speed, and that speed turns the universe into a place where distance always comes with delay. That is what a light year really means. A light year is not a measure of time. It is a measure of distance. The distance light travels in 1 year. It sounds like a calendar word, but it is actually a ruler. And when you use that ruler, you begin to notice something quietly unsettling. You never see the universe as it is right now. You see it as it was when the light began its journey. Start with the closest example. Sunlight takes a little more than 8 minutes to reach Earth. That means the sun you experience is always 8 minutes old. If something changed at the sun this instant, you would keep seeing the old sun because the new information would still be traveling toward you. Your brain treats this as now because 8 minutes is small in a human day, but it is the same rule that governs everything else you will ever see. Move outward, the nearest star system is more than 4 light years away. Any message or image from there is already years delayed when it arrives. A conversation becomes slow by design. Even the closest stars live on the far side of patience. Now look at Andromeda, the nearest large galaxy. It is about 2.5 million light-years away. When you see Andromeda, you are seeing it as it was 2.5 million years ago. On Earth, that was long before recorded history, long before cities, long before agriculture. The light leaving Andromeda then has been traveling ever since, crossing intergalactic space, arriving at your eyes tonight as if it belongs to the present. This is the emotional twist hidden in astronomy. You live in the past, not metaphorically, literally. Everything beyond your immediate surroundings is a delayed message. The sky is not a view of now. It is a stack of older moments arriving all at once. And the farther you look, the deeper into the past you fall. Distant galaxies are not only far away, they are younger versions of the universe itself. The light you collect becomes a kind of time machine. It shows you what the cosmos used to be, not what it is. And here is where the question starts to sharpen. If distance equals delay, then forever might not be a long road. It might be the point where delay becomes so great that contact becomes meaningless. And we're about to approach the first cosmic boundary that comes from this simple fact, the edge of what light has had time to bring us. The farther you look, the more you time travel. Space feels like a place you could cross if you had enough fuel and enough time, a long road with no end. But the universe isn't built like a road. It's built like a fabric, and that fabric can stretch. This is the part that changes what forever means, because the universe isn't simply sitting there while you travel through it. The universe is expanding. A simple way to imagine it is to picture a loaf of raisin bread baking in the oven. As the dough rises, every raisin moves away from every other raisin, not because the raisins are actively crawling through the bread, but because the bread itself is expanding between them. If you lived on one raisin, you would look out and see the others receding in all directions. Space behaves like that on the largest scales. Galaxies are like the raisins. Most galaxies aren't flying through space away from us like rockets. They are mostly carried apart because space itself is stretching. At first, this sounds like a detail you can ignore. Expansion feels slow, but the farther away a galaxy is, the more expanding space lies between you and it, and the faster it recedes. At great enough distances, the rate of separation becomes enormous. And this is where a sentence that sounds impossible becomes true. Some galaxies are receding from us faster than the speed of light. That does not violate relativity, because nothing is locally moving through space faster than light. In their own neighborhoods, galaxies are not breaking the speed limit. What is growing is the space between neighborhoods. This matters because it means distance is not a fixed challenge. The universe can change the challenge while you attempt it. the target can be carried away by the stretching of the fabric itself. So forever is not just a large number of miles. It is the feeling that the universe can outrun you. If the space between you and a destination grows fast enough, no amount of patience helps. You can travel forever and still fail to arrive, not because you are too slow, but because the universe keeps increasing the distance. And that raises a quiet question that will guide the rest of this journey. If the universe is expanding, where is the point you can never reach? Because there is such a point, not a wall you crash into, but a boundary you can approach only in theory. Even light can lose the race, not because it's slow, but because space grows. When people hear the phrase, the edge of the universe, they often imagine a wall, a border you could reach if you traveled far enough, like the end of a continent where land becomes ocean. But the universe doesn't have that kind of edge, at least not in any way we know how to describe. The first edge we can talk about is not an edge of reality. It is an edge of information. Because the universe has an age, it has been expanding for a finite amount of time. And light, no matter how fast it moves, has only had that finite time to travel. That creates a horizon around us, a boundary separating what has had time to send us information from what has not. This is what we mean by the observable universe. The observable universe is not everything. It is everything we can, in principle, see, because its light has had time to reach us since the beginning. It is the part of reality that has been able to communicate with us. A calm way to picture it is as a sphere centered on you, not because you are special, but because you are the observer. Every direction you look has a maximum distance, a point where light has not had enough time to arrive. Inside that sphere are galaxies, clusters, and faint structures stretching across space. Outside that sphere may be more of the same or something stranger, but outside it, there has not yet been time for a message to reach you. And this is why the word edge is misleading. When cosmologists talk about the edge, they are not claiming reality ends there. They are saying our ability to see ends there. But once you accept that, a new question opens naturally. If the observable universe is only what has had time to reach us, what lies outside it? More galaxies, more space, more time, perhaps the same physics repeating beyond our horizon, or perhaps something we have never had the ability to measure. And there is a deeper twist still. Even within what is theoretically observable today, the universe's expansion can create another kind of boundary, one that doesn't only limit what we can see, but what we can ever reach. This isn't the last boundary. There's another one that matters more. There is a boundary more unsettling than the edge of what we can see today, because it isn't just about the past, it's about the future. The observable universe tells you what has had time to reach you so far. The next boundary tells you what can reach you ever again. Cosmologists call it a horizon too, but this one behaves like a door that slowly closes. It is sometimes described as the universe's event horizon, a future visibility boundary created by expansion, not a wall, not a sudden cutoff, a gradual separation that becomes permanent. The universe is expanding, and not only expanding, but expanding in a way that can accelerate. When expansion accelerates, distant galaxies are carried away from us faster and faster. Light from them may still be reaching us now because it began its journey long ago, when the distances were smaller and the door was more open. But as time passes, some galaxies will cross a threshold where new light they emit will never reach us. So there are galaxies we can see today, and yet can never truly contact. We are receiving their past, but we will never receive their far future. Even if they keep shining, the universe will carry their newer light away. And this leads to a strange kind of cosmic FOMO, not the anxious kind, but the quiet realization that the universe is changing what will be knowable. The night sky is not a fixed museum. It is a living scene. some parts of it are drifting beyond the possibility of future contact. If you could wait long enough, the far universe would grow dimmer, not because galaxies stop existing, but because fewer of them would be able to send you new light. Over unimaginably long times, a future observer in our galaxy could look out and see a smaller and smaller island of visible cosmos. So forever becomes something sharper than a long time. It becomes a line in the future where communication stops, where the universe's expansion turns distance into permanent separation. And this boundary is not far away in the emotional sense. It's already forming right now, while you look at the sky and assume it will always look roughly the same. So the question naturally changes again. If the universe can close doors over time, what happens to forever as time passes? The sky is quietly losing pieces you'll never get back. At this point, most minds do the same thing. They look for a loophole. If distance becomes delay, if expansion closes doors, if forever is a horizon you can't cross, then the obvious question is whether there is a way around the rules. Not by traveling faster in the usual sense, but by changing what travel means. This is where ideas like warp drives and wormholes appear, not as promises, but as thought experiments. Some equations in general relativity allow spacetime to be shaped in strange ways. A warp that changes the geometry around a ship, or a wormhole that connects two distant regions through a shortcut. On paper, these ideas can avoid breaking the local speed limit because the ship is not outrunning light through space. The geometry is doing the work. But the difficulty is enormous. Many such solutions appear to require exotic conditions, forms of energy we may not be able to create or stabilize, and they often raise problems with causality, the normal order of cause and effect. So the careful conclusion is this: the math can hint at shortcuts, but nature may not allow them in a usable way. Even if a shortcut exists on paper, the universe may charge a price. There is another reason forever feels so strange, and it has nothing to do with distance. It has to do with direction. Time as we experience it points one way. You remember the past, not the future. You can spill a glass of water and watch it spread across the floor, but you never watch it gather itself back into a glass. You can burn paper and turn it to ash, but you never see ash reassemble into paper. These are ordinary experiences, and yet they hide one of the deepest rules in physics, the arrow of time. The arrow of time is our name for the fact that certain processes run naturally in one direction, toward disorder. In physics, we call that tendency entropy. Entropy is often described as disorder, but a better way to think of it is as the spreading out of energy and possibilities. Systems tend to move from fewer arrangements to more arrangements, from concentrated energy to dispersed energy. This is not just philosophy, it's why memory works. To remember something, your brain must change. It must store information. That storage requires energy. It produces heat. It increases entropy. In other words, the act of creating a record is tied to time moving forward. So when people say beyond time, it's tempting to imagine a place outside the universe where time doesn't flow. But in physics, beyond time often means something more subtle. It means conditions where the usual arrow becomes meaningless, where events don't produce stable records, where change is so slow or so uniform that nothing like progress can exist. And this matters because forever is not only about how long the universe lasts. It is also about what kinds of experiences remain possible as time stretches out. A universe can exist for a very long time and still become a place where nothing new can happen, because the energy gradients that drive change have faded. The arrow of time still points forward, but there are fewer and fewer interesting steps for it to take. The universe becomes quieter, flatter, more uniform. This is why forever can be deceptive. It sounds like infinite richness, infinite events, infinite stories. But entropy suggests a different possibility. As the universe ages, the future may contain more time, but less happening. So the question shifts again, gently but inevitably. If time points one way, and the universe moves toward a state where change becomes harder, what kind of future is even rememberable? Because a future without change is not a future you can live inside, even if it lasts forever. Forever might not be long, it might be empties. If forever points forward, then the most comforting thing we can do is give it shape. Not with panic, not with drama, but with a calm timeline, an honest tour through what comes next, according to the physics we understand. Right now, you live in what could be called the bright era. The universe is filled with stars, and many galaxies are still forming new ones. Gas clouds collapse, fusion ignites, new suns are born. The night sky, from the right place and the right planet, can still look alive. But this isn't guaranteed forever, because star formation depends on fuel. Galaxies need cold gas, and over cosmic time that fuel is gradually used up, heated, or scattered. So the first step in the far future is not a sudden catastrophe. It is a slow decline. Star formation rates decrease. Galaxies become quieter. The bright blue stars, which burn fast and die young, become less common. More of the light in the universe comes from older, redder stars that linger for longer. Then there is a second shift, and it comes from expansion. As the universe continues to expand, many galaxies outside our local gravitational neighborhood will recede farther and farther away. Over immense timescales, their light can become stretched and faint. The visible universe, from the point of view of a future observer in the Milky Way, would gradually become less crowded. After that, the long Middle Ages of the cosmos unfold. Stars continue to shine, but fewer are born. The universe becomes more dominated by long-lived, low-mass stars, small red dwarfs that can burn for trillions of years. They are dim, steady, and patient. And eventually, even that quiet era ends. When the last reserves of star-forming gas are gone, no new stars can be made. The stars that already exist continue living out their long lives. Larger stars die first, leaving behind white dwarfs, neutron stars, and black holes. Smaller stars persist far longer, but the direction is the same, toward fewer active suns and more stellar remnants. The last star is not a dramatic final moment you could easily witness. It is a slow fading, a long, gradual thinning of light. And this is the part that creates a gentle kind of FOMO, not anxious, but reflective. Because whatever happens later, you are here now, in an era when the night sky can still look rich. This is the last era where the night sky looks alive. When people imagine the end of the universe, they often picture an explosion, a collapse, a sudden event with a clear final frame. But one of the most likely endings is quieter than that. It is called heat death. Heat death doesn't mean everything becomes hot. It means energy becomes evenly spread out, differences fade, gradients disappear, and without gradients nothing can do work. No engines, no weather, no chemistry that can keep reshaping itself into new complexity. A universe can still exist and still be, in a sense, finished. In that far future, what remains active the longest are the darkest objects. Black holes can outlast stars. They can persist for staggeringly long times, slowly absorbing what passes near them. But even black holes are not forever. In modern physics, they can slowly lose mass through an incredibly faint process called Hawking radiation. So forever may not mean endless events. It may mean endless quiet, a cosmos with time, but with almost nothing left that can happen inside it. And that's the contrast that makes the present feel bright. The end isn't an explosion, it's silence. We've been talking about forever as something vast, horizons, expanding space, distances so large they become time itself. But there is a second way to approach the word, and it flips the entire scale. because the universe may have limits on the other end, too. At the smallest scales we know how to describe, the smooth idea of space and time begins to break down. Physics points to quantities like the Planck length and the Planck time, numbers so tiny that our usual concepts of here and now may stop behaving normally. They are hints that spacetime itself may not be infinitely divisible. We don't yet have a complete theory that unites gravity and quantum mechanics, and that gap matters because it suggests that beyond space and time is not only a faraway horizon, it might also be a microscopic boundary where the universe stops being continuous and becomes something stranger. So when we ask how far forever is, we get two answers at once. One is written across billions of light years. The other may be written inside distances too small to imagine. The universe has two edges, the very large and the very small. So how far is forever? After all this distance, all these horizons, the answer is quieter than the question. Forever is not a place you eventually arrive at. It is not a road you can travel if you just keep going. Forever is a boundary of access. It is the line where information becomes unreachable, where travel becomes meaningless, where the universe's geometry turns someday into never. Some edges are behind us in the sense that we can only receive the past. We look outward and we see older and older light arriving. We time travel every time we look at the sky. Some edges are ahead of us in the sense that expansion creates horizons that close over time. There are galaxies we can see today whose future light will never reach us. The universe is quietly sorting reality into what can remain connected and what will drift away. And at the deepest level, there may be edges at the smallest scales too, places where space and time themselves stop behaving like the smooth stage we imagine. When you put all of that together, forever becomes something you can finally hold, not in your hands, but in your understanding. It's also a reminder of where you live in the timeline. You are here during a bright era, when stars still form, when galaxies still glow, when the sky still looks alive. Your life is brief, but it happens during one of the richest chapters the universe may ever offer. And you don't have to reach forever to understand it. You only have to see what it does to distance, to time, and to what can be known. If you enjoyed this journey, take a moment to like the video and subscribe. It helps the channel, and it helps these calm stories keep finding their way to people who need them. And if you're still awake, tell me in the comments where you're listening from and what time it is there. I love seeing how far these quiet conversations travel across Earth. For now, let the word forever soften again into something simple, not a threat, not a promise, just a name for the universe's most distant boundaries, and the quiet fact that tonight you were here to notice them.